Hi, everyone. Thanks for joining today. This is RFD discussion, a quick deep dive into Teleport's RFDs. I'm Ben with the Dev Relations team. Today I have Nick and Andrew. Before we dive too deep into why we are using RFDs and our feature on HSMs, Nick, do you want to give a quick intro?
Sure, yeah. I'm Nick Clausen. I'm a backend software engineer here on the Teleport core team. And I joined about 4 months ago, and I've spent the past few weeks here working on this HSM RFD implementation.
And I'm Andrew Litvinov. I'm also a backend engineer on the core Teleport team. I've been here for a year and a half and working on all kinds of stuff.
Cool. So to kick it off, Andrew, your name is on top of this RFD. You've been here a year and a half, and I remember you sort of like bringing in the kind of concept of a RFD. Do you want to talk about why you introduced it and sort of what have been some of the pros of using an RFD throughout the later half of your tenure here at Teleport?
The whole idea was inspired by my previous experience, previous companies, and the first couple of months at Teleport, where when there is a formal design discussion, people use something like a Google Doc or some sort of a shared document where everyone just kind of jumps in and comments, and eventually the rate of comments gets low enough that you think it's done and finished. But it's always bothered me is there's not really a clear kind of sign-off process. There's rarely a clear structure to it. It's just kind of, it's all very up in the air and subjective of when it's done. And especially if you need to, some reviewers are more experienced or important than others, where they are very familiar with the domain, for example. It's hard to tell whether they looked at it and they approve it, or they didn't even look at the document at all, if there's no comments. So the idea here was actually borrowed from the Oxide Computer Company, which they have exactly the same. This is what they came up with. And RFD, by the way, stands for Request for Discussion, but essentially it's a design doc. So their approach is kind of the same, where it's all Markdown files on GitHub, but they just built a lot of very cool tooling around it to make the process even smoother. For us, we kind of just adopted the Markdown files on GitHub part, with PRs being our actual review medium, and some very, very approximate structure to the contents and the numbering of the RFDs.
Yeah, so then the key, you just have like a what, a why, and then the details.
Mm-hmm.
And
then basically, everything goes into the details section. The first two are just there they're like the parts that are pretty much always missing from design docs. Is like 2-sentence overview of what it is before you dive into the nitty-gritty details, and why are you actually doing it in the first place.
And I guess you do the PR and then you go through the different states. So I think the thing that I've seen is sort of they get updated and changed as things get implemented and details get found out, which I kind of like that it then becomes the canonical source of the design sort of changes over time, and you can always keep updated, which definitely fix that Google Doc problem.
Yeah, most of the time, especially because we keep these in the same GitHub repo as the rest of the code base, it kind of nudges you towards updating the RFD if you change something. You discover that something doesn't work during implementation, you have to adjust the design. It's very easy to update it in the same PR.
And we're on, I think, 37 now. So in 8 months, we've done some good progress on our RFDs. Is there anything, when people are making a decision, what would be the thing that would decide you should make an RFD or not?
I mean, the answer is probably pretty much always write an RFD. Really, it's about the scope of the thing. If it's a bug fix that's trivial, or some kind of addition that's very, very straightforward, it doesn't really need to be discussed. But if you're touching, API and config file formats and some user interaction bits, if there are kind of multiple parts of the system come into play and somehow affect each other, then it might be worth writing an RFD. Of course, anything major, restructuring APIs or anything with big security implications or major new features, that's pretty clear.
Yeah. And Nick, how's it been for yourself onboarding?
It's been good. It's nice to be able to go and look at the RFDs for how certain parts of the system are designed, and having a single place where you can find all your design documents and read and comment and review other people's documents. I've written one RFD now as well.
Oh yeah, which one's yours?
So mine actually, I haven't merged it yet. It's 35.
Okay.
It's a no, or I
Or
guess it's
maybe
not 35.
we have
Maybe
like a number
someone stole it.
problem.
I stole it.
We have a collision.
But I think this is a useful thing is the draft RFDs. Let's see if we can find it.
Yeah, so the Oxide folks actually solved that specific problem where they have like a central system that deals with reserving these numbers and tracking them. So they don't have to deal.
Let's see. Oh, I guess Professor Jones XX.
There. Simplified no joining for AWS.
And then I think this is also kind of handy too. You have like the draft, kind of like in progress RFDs.
Yeah, we got the draft reviewed internally, and then we actually ended up sharing that with a customer that was interested in joining the feature, and they got a chance to review it. And we got a security review on that one as well before we. I should probably merge that now. I'm going to start implementing that one soon here.
The simplified no joining. Yeah, I think that's the benefit of an open core company. If we had Jira or like even Google Docs can be difficult to like share externally, and knowing who you're sharing it to. So I guess by default working in public, it probably helps us a lot. So let's dive into RFD 25, which has both of you. So HSMs, like you said, Andrew, the what and the why is always kind of like a bit short, but do you want to give a quick overview of why Teleport has added HSM support?
Sure. So just for context, HSMs are hardware security modules, which are typically hardware devices that store private keys, like very, very high value private keys. And that's the whole concept, is you put them into an HSM and you can never extract them, not trivially anyway. So it kind of protects them from, even if your server's compromised, you can really only use that HSM for so long until it's unplugged. So the reason we added it is, I mean, really, like with most features at a startup, is because the customer needed it. We're like solving a problem that someone has. Specifically, HSMs affect financial companies who are subject to a lot of regulations and very specialized requirements about their IT infrastructure. So in this case, there was at least one financial customer who came and said, like, hey, we need this because otherwise we can't run we can't teleport to certain systems that without like violating this compliance. And I think it's PCI that they're concerned about. But this is not my area of expertise. I don't really know a lot of details about specific regulations, but that's the gist of it. But at the same time, we were kind of thinking about doing it for a while anyway, because it's just it's a responsible security thing to do, because with Teleport and for the listeners, Teleport is kind of like an access gateway, and the way we grant access is via TLS or SSH certificates. So that means we have a certificate authority hosted by Teleport that basically gets you access, can get you access to anything if you control that certificate authority. So it only makes sense to protect the keys with that certificate authority as hard or like as heavily as we can.
And so in this case, if someone was to get access to the auth server and it was configured with the HSM, what would be the sort of like attack? Would they be able to exfiltrate any private key data, or is it 100% more secure? Is it just a little bit more secure? Like, what was our sort of take as far as sort of attack tree is concerned?
So it depends on what kind of compromise. If it's a remote, purely like software compromise, as in they have like a remote code execution, they would need to have root access on the machine or be able to control the execution of the teleport process itself because it runs as root. And in that case, they can create new certificates, sign them with the certificate authority, as long as they have this persistent access, as long as their machine is live and HSM is there and they are not caught. But as soon as you fix whatever hole they got in through, they can no longer do anything. And they are not able to exfiltrate or like download the private keys for the CA when they have access. They can only mint new ones. So they can only do the operations that the CA can do, but they cannot actually take the CA and pull it out, if that makes sense. Then there is the other part, which is physical compromise. So when you actually go to whatever data center this is in, pull out the machine and including the HSM. So with the machine and the HSM in hand, you can probably do anything. There's obviously kind of other protections like disk encryption. The HSMs have pins for access, so you can just pull out HSM itself without knowing the pin and not being very lucky. So that's also kind of difficult, and obviously you have to deal with bypassing physical security of the actual data center this is hosted in. So it's not bulletproof. It doesn't mean that CA is secure 100% and nothing could ever happen to it, but it's really, really hard to have a long-lasting serious compromise.
And then I know if you go like way back to like RSA kind of conference like 10 years ago, everyone's sort of selling these like large rack HSM devices, which cost like 200 grand. And now we've gone to, you can get like cloud HSMs for, like $1 a month. Is there any difference between these two HSM variants?
Yes. So yeah, like the cheapest ones hardware-wise you can buy is something like this. It's like a UVHSM, just literally like tiny little USB size thing, which costs like $600 still, but it's a lot cheaper than the big server rack mounted ones. And the real reason people buy those like huge, they're standalone servers. They're not a device you plug in to something. They're like a server that has a remote API that you execute these commands over. And the reason is performance. Like they basically, it's a dedicated machine just to do all the crypto operations, all the signing and verification and stuff. Other than that, cloud HSMs, at least the Amazon one, they I think comply with all the same regulatory requirements as the physical ones. So like in legal terms, I don't think there's a huge difference. It's a little easier to develop against the cloud HSM, of course, because first of all, you can actually obtain it very easily as a developer and get access to one temporarily and not share a big thing somewhere in the data center. And also the API is can be a little cleaner. So it does also expose a PKCS-allowing API, but there's also like a actual REST style API to it, which is a lot more convenient. Yeah.
If I'm remembering correctly, I think cloud HSM is $1 per hour rather than $1 per month, so a bit more than that.
It's not cheap, but it's cheaper.
Cheaper than the big rack unit, yeah.
Wow, yeah, definitely adds up. I mean, I think I have the AWS HSM page here. And I guess you have like full control over your like KMS keys too. So all of your other secrets, I guess you can have sort of more control over that.
Yeah, and like
encryption.
Like AWS, like the cloud HSM thing really is hosted on those same big server blades that are HSMs. It's not like purely a software solution. It's an actual HSM running under the hood. So really what you're doing is the same thing you do with virtual machines, where you just share the hardware resource and have some like kind of tenant isolation things that they take care of for you. But really it's the same exact device under the hood.
Okay, so let's dive into some of the backgrounds. We'll talk about HSM operations.
I feel like Nick is better qualified to answer this.
Sure. Yeah, so HSMs, they can generally do the operations that you need with your private keys. You can, first of all, generate key pairs. Usually different HSMs will let you generate a few different types of key pairs. And the private key is always just going to be held on the device. Of course, you need to export the public key, so you can do that. You can also do encryption and decryption on HSMs, which we're not using right now, but that's a feature that a lot of them have. Signing with the private key is the big one that we're using. And obviously, if you don't have access to your physical private key, the HSM is going to do all the signing, and you can look up and your keys and list the keys that on the device that your access token has access to.
Yeah, I also like that you say like HSMs are a product category, like storage devices and monitors, not a standard. And I think if you found that they've like different between providers about what do you get out of the like HSMs.
Yeah, they all generally comply to the same like minimum subset of features, which is whatever is contained in the PKCS 11 standard. But there's also all kinds of bells and whistles. So the bigger, more expensive the HSM is, the more features will be crammed into it, even if no one really uses them. But they'll be available.
Do one of you want to explain what PKCS 11 is? Because it's used a lot.
Yeah, good. You
Sure.
actually worked with it.
I worked with the library wrapping it. But yes, yeah, PKCS 11. I might be technically wrong here, but it's I guess a standard for an API that a lot of HSMs implement. So the way it usually works is you have a library that you can, I guess you could statically link it or dynamically link to it, which is going to interface with your HSM, however that actually works, whether it's over the network or if it's plugged into your server. This basically C library that you're going to link to is how you're going to interface with your HSM. So usually there's different libraries that you can use that are going to wrap the actual C API. We're using one of those. Yeah.
And then for, I guess we're going to say like each kind of vendor has their own like custom SDK. And I think the idea is we've used PKCS 11 to make a generic solution that will like integrate across all of these providers.
Right. So yeah, when they're developing their HSM and they want to sell it, they'll implement their own PKCS 11 implementations that anyone can use so that it's compatible.
Yeah. And just like at a higher level, PKCS 11 is literally like, you can think of it as a C header file almost. It's like a C API to do crypto operations, like in a very abstract way, like creating keys, listing keys, signing stuff, encrypting, decrypting stuff. And that's like, it's a layer of abstraction that's used to hide the underlying implementation details of how this is implemented. HSMs are one of the most popular use cases for PKCS 11 APIs, but there can be other devices. So another one type of device is PIV, which is personal identity verification, which is basically smart cards. And a lot of YubiKeys have that built in as a feature. So it's not unique to HSMs. It's just this interface to abstract like some backend thing, which can be software, hardware, whatever, that deals with cryptographic operations. And so that's why it's a really good abstraction layer where it can hide the details of how the hardware interactions work with a specific HSM. And the kind of the vendor is supposed to do a translation from PKCS 11 to whatever their hardware interface is. And then pretty much all of them implement it as kind of like an expected thing from all HSMs now.
Yeah, I found this interesting note too. They say like HSMs don't guarantee that the key can't be stolen. Instead, like there's like a tool for exporting the private key.
Yeah, it's so HSMs, historically have been developed for this one specific, private key protection requirement. But over time, a lot of companies try to, there's like some quirks of their infrastructure or some like historic baggage and legacy stuff. And it's really hard for them to just switch into this model that a key is always an HSM and that's it. You have to kind of like treat them as very high value physical devices. And so they eventually propagated these extra features into HSM specs that, well, you can ideally generate the key on the HSM and never export it, but you can also like get a key that you already have and just put it into HSM. It's one thing. And then there's the opposite is some people were like, well, I don't really want to be very limited with my HSMs and not be able to back up any data. So I want a feature where I can, when I create the key in there, I add a special flag. And then with that flag, the key is actually exportable. It's not exactly exportable. There's like some extra encrypting happening when you pull it out. But the end result is that you can take out a key and either back it up to later restore it to the same HSM or a different HSM, or you can transfer them from one HSM to the other, or you can get really creative and actually pull out the plain text private key. But this is not like a deal breaker. Really, you have to opt into that behavior. By default, if you create a private key in HSM, it's not possible. You have to explicitly say I'm gonna plan to do this thing, so this key better be compatible.
And then I guess you have your security procedures around not, putting a screenshot of it on 1Password or something.
Right.
Keeping it.
Yeah, and to clarify, like Teleport will not use that feature. We specifically will always make sure the keys are not exportable because it's just a much easier security model to reason about.
Yeah. And then so Teleport has a CA, because we have like multiple CAs, the host, user, and for JWT. And I think another core feature of Teleport is that we support like rotation of the CA. Was there any thing with HSMs that we needed to take into consideration with integrating HSMs with Teleport CA?
I can describe the CAs, but Nick has dealt with all of the issues of our rotation to make this work. So let's do that. So CAs, we have 3 CAs in Teleport. Originally Teleport was as an SSH only solution. There was no like TLS, there was no Kubernetes access, nothing like that. So a lot of this naming really is very SSH centric. So that's where you have the host CA and the user CA. Practically what this means is host CA issues certificates only for servers and services. So all of the Teleport components like your database service, SSH service, all these things that are running as Teleport binary and then joining to the cluster, they're all getting identities and certificates signed by the host CA. User CA is obviously for users. So whenever you log in as a user, you get a CA signed by that. And the idea is that those two are separate. So if you compromise one, you don't completely compromise the entire system. You only kind of partially destroy the security model. And then the JWT CA was added, I think, a year ago when we were building application access, which just means like web apps proxied through Teleport. And so because web apps or browsers don't generally support MTLS or even SSH connections out of the box, which is what we use for everything else, we had to use, or we chose to use JWTs as a kind of a session cookie, I guess. Actually, no, sorry. These JWTs we pass over to the target application that we're proxying, and we embed the identity that Teleport kind of figured out about the user. And so the end application can check those to see who the user is that logged in without implementing their own login flow. That's kind of the whole idea. So that's when the JWT CA was added, and it's only for that specific use case. We could have used the host CA, but it seemed a little better to isolate that CA. And Nick, you can explain the rotation story.
Sure. So the issue we had when adding HSM support is really that there was sort of an assumption that in the cluster you only have one active private key at a time. But if you have a high availability cluster where you have multiple auth servers, and each one can be connected to a different HSM. Each one is going to have essentially a separate private key and public key that we need to be able to store and reference in the CA. So with our current implementation, where it really only stores one active key pair, and when you're in rotation, we'd have an additional trusted key pair. That wouldn't really work for storing the extra keys. So what we ended up doing is, well, I'll explain. What we currently had was basically just an array or a list of two key pairs, where the first one would be the active signing key, and the second one would be, if you're in the middle of rotation, your additional trusted key. So that would be generated when you start rotation, and then at a certain phase of rotation, you would swap those two so that your new key is used for signing and the old one is still trusted. But when we were introducing HSMs and you're going to have multiple active keys, just having them in a list wasn't going to work. So now you can have a set of active keys and a set of additional trusted keys. And then during rotation, you can just swap the entire set at once rather than referring to different, array indexes.
And does the I know you can set cert time rotation. Does that impact it, or does it happen sort of immediately?
Cert time rotation. Oh, so
I
the
know if
time
you're like
limit.
rotating your CA, you can set like, I want to rotate over, let's say like 12 hours. So all of your certs get time to fully update and get the new CA.
Right. Yeah. So our rotation has 4 phases, I believe. There's init, update clients, update servers, and then standby, which basically means you're done. So you can either go through those phases manually or set up auto rotation, where if you set a period like 12 hours, it would split up each phase over, a third or a quarter of that, if I can do math correctly, and automatically execute those phases. So the reason that you usually want to have some time between those phases is because all of your hosts and all of your clients, everything that needs to have a signed certificate needs to get a new refreshed certificate signed by the new CA, so that it's still going to be trusted once the rotation is complete. So when you set,
And they also need to get all the new CA keys to verify everyone else's certificates.
right, they need to know which public keys to trust as well.
Cool, that's a good overview. So let's dive into the architecture. I think for people who aren't familiar, a lot of more advanced configurations you configure using our teleport.yaml config file, and there's multiple variants in which you can set this up. If you follow our getting started, you put this all into, you can set up the auth, proxy, and node on one node, although for security and high availability, we recommend splitting out the auth and the proxy into different services and customizing with teleport.yaml, and there's multiple configurations. I don't know, do we have a example of the?
Should be.
Oh, here we are down here. So for people who are setting up teleport with a HSM, can you just talk through about what this configuration means and sort of what the setup looks like?
Sure. Yeah. So I should have updated this in my last PR actually, because there's, just a couple minor changes, but essentially, yeah. So when you're configuring your auth service, we have this new CA key params field with PKCS11 within it. I guess we set it up this way so that it could possibly be extensible in the future. But in your PKCS11 section, module path is just the path to wherever you have your PKCS11 module from your vendor, so that we can load it. Label, I think I changed it to token label, is a way of identifying the token that you use to connect to the HSM. So whoever's setting this up, usually when you set up the HSM, you create different users, and they can each have a token that gives them access to a different set of keys and different set of operations within the HSM. So depending on which vendor you're using, you either use a token label or a slot number. So we ended up supporting both those options for identifying essentially the token that you use to authenticate with the HSM. And then
is the
there's a PIN as well.
token, is token your kind of like access object, or is it a identifier for a private key?
It's an access object. It doesn't identify a specific private key, but rather how Teleport gets access to the HSM operations and access to all of the keys that it created is essentially what it has access to by default.
And so once you sort of populate all this, like, is there any, what's the module path if you use AWS Cloud HSMs?
There's a default path if you're running on EC2. I forget exactly what it is. I could bring it up. But,
do you have to do like an instant assume role so it can like access the HSMs on their behalf, or?
You actually have to,
Go ahead.
You have to install their SDK on your instance. They may have AMIs with it, or you could make your own AMI with it installed. But you essentially install their Cloud HSM SDK, and it includes their PKCS11 module at a certain path that you would configure here.
Yeah, that's kind of the idea of using a PKCS11 interface, is that we don't really know or care about how AWS plums it.
Yeah,
they just have to give us the SO file, the module, and internally that module is dealing with all of the authentication to it on the AWS side and all of that stuff. But we just know that it's a PKCS11 thing. We don't even know that it's AWS.
Yeah.
And then when it's, so let's say you have this new teleport.yaml, everything's sort of set up right, you start teleport. Is there any indication that you know that teleport's using a HSM or not?
Yeah, there will be some log lines. The thing is, if you already have a teleport cluster set up,
I think about this migration here.
Yeah, you have to do a migration because obviously you can't just make new HSM keys and nothing's going to trust those right away. So you have to do a migration step. So what we're doing for that now is after you set up an HSM, it will, you need some keys initially so that you can have tctl authenticate with your with the auth server and perform some operations. But so when you configure HSM and startup, it will generate those, but then you actually need to do a CA rotation to get your HSM keys to be the active keys in the cluster that you're using. So we talked briefly about CA rotation earlier, but yeah, if you're setting up an HSM in an existing cluster, you need to do that. Or if you're setting up multiple auth servers in a new cluster, any additional auth servers that you add with their own HSM, you're going to need to do a rotation to get the rest of the cluster to trust those keys.
Yes. Nick can probably attest to this, but the CA rotation is really the most complicated part of this whole feature. Connecting to PKCS11 stuff, issuing keys managed by HSM and all of that is not really that difficult. It's just some plumbing and finding the right library. Mm-hmm. But CA rotation has just so many possible states and permutations of what can happen. For example, you can be starting creating a brand new cluster with a in-memory private key, or you can be creating a new cluster with a key hosted in HSM. That's one case. Then you can have an existing cluster with a plain text key, and you add a new auth server with an HSM, and you have to have a story for how you get that HSM to be trusted and how you kind of allow it to sign stuff. Then you have you have a cluster with existing HSMs and auth servers, and you add to that. What happens when an auth server with an HSM disappears? And all those things have to be taken into account and never get into a state where you start signing certificates with a new HSM that not all of your clients have already trust. Mm-hmm. Because otherwise there's going to be a lot of connection issues and trust errors and so on, that like the cluster is going to get broken. So we have to be really careful to analyze every single thing you can do to your cluster, and all of these additions, removals of HSMs and plain text keys, and like figure out, are we ever going to get into a wedge state where we either can't sign anything new, or are signing something new with untrusted keys?
Which is, I guess, to your point here, it says don't set it grace period 0 or very short time, because I guess that's sort of how you get into that problem.
Yeah, that's one way you can get there, is if you like we don't during CA rotation, obviously all of the hosts and all of the clients have to update their certificates and their like CA public keys that they trust. But there's not really an explicit acknowledgement step where the auth server knows that, okay, all of my hosts and all of my clients have updated. There's not like a callback that they say, okay, I'm done. Instead, we just rely on these periods where we say, okay, we're gonna release the new keys out into the wild, and then we'll wait this number of hours for everyone to update, and we're just gonna assume that it is enough time and happens. It's kind of up to the cluster admin to ensure that that's enough. So grace period is like, if you set it too short, like obviously that window is going to be short, not long enough for everyone to get the new set of CAs, and a lot of stuff breaks.
Yeah. So I guess for our large customers, people running like 10,000 nodes, they already kind of know through their current migration how long it takes for the whole fleet to update.
Yeah, and HSM is not going to make that part any different time-wise. Like issuing and propagating all the keys with HSMs is probably about the same as with plain text keys, but you do have to be more careful and do the rollout more gradually with HSMs.
Yeah. Is there any performance overhead of using the HSM?
Have you benchmarked it?
I haven't noticed. Well, depending on which HSM you use, generating the key can take a fraction of a second, which we have to generate 5 keys to get all the CAs, so it takes maybe a second or two, which is a little bit longer than it was in software, but not that bad. The other time when you're interfacing with the HSM is when you're signing new client keys, either host keys or user keys or certificates. Sorry. But I haven't noticed with any HSM that I'm testing any additional slowness with that. I was doing some testing last week with spinning up a larger cluster. Ended up just going to about 1,000 nodes, and didn't notice any significant performance impact from using the HSM. Yeah, I was just going to say the one difference with CA rotation that you have when using HSMs is that every auth server now needs to create new private keys. Before, when all your keys are in software, you can do the whole rotation on one auth server because every auth server can just load the same private key. But if you have a cluster with multiple auth servers and they all have HSMs, every auth server needs to watch the state of the rotation as well and create new keys during the init phase.
So am I right in thinking, so if I had 3 auth servers, I would have 15 private keys, like 5 per host? Is that how they get shared? Or
there's three CAs, so that's 9 private keys. But then during the rotation, you double that. So each auth server, each HSM will have two logical CAs, the new one that you're rotating towards and the old one you're removing. So that's going to be 18 private keys during rotation in the case.
And then what would happen if one of those HSMs was to go offline? The YubiKey was to get unplugged?
Basically, I mean, if you lose your HSM, you lose those private keys. You don't have access to them anymore. So what we currently have is basically, you have your mouse on it there. You have to remove varlib teleport host UUID, and that will basically the auth server will restart and say, oh, none of these keys. I don't have any keys in the CAs that are referenced to my UUID, because it will generate a new UUID, and it will think that it's basically a new auth server in the cluster, and you'll have to do a CA rotation again for it to generate new keys and get get back into the cluster and trusted by everyone.
And would you have to like re-invite nodes as well?
Yeah. So if you lost all of your HSMs from like, if you had one auth server with an HSM and that's it, and you lost access to the HSM, you would have to basically re-bootstrap the cluster from scratch because none of the nodes have the new CA certificate to trust, and all of the connections break.
Yeah.
So for that reason, we do suggest that you have an HA set up with HSMs, with different HSMs, not one shared one. For that reason, because the HSM disappears, you're done. In the old like pre-HSM plain text key days, you can have one auth server, and as long as you have the backend data, like the storage data, still available, you can delete that auth server, put a different one in place, and we'll just load up the same plain text key from the backend, and you won't notice a difference. This just doesn't work with HSMs the same way. So you do need to have HA, and you do need to be kind of rotating one thing at a time, like adding one auth server at a time or removing one at a time.
So for customers, we're like recommending at least 3 auth servers and 3 HSMs for high availability.
Ideally, yeah.
That's probably why it's all PCI. So the financial industry has the money to afford all of the HSMs. All right. And anything else? I was kind of talked about reliability. Any other? Compatibility. Near the end. So what have you tested it with, Nick? I know we have these 3 here.
Yeah, essentially that list there is what I've tested it with. Soft HSM is just like a software library, not a real HSM. So I do a lot of our automated tests run with that. They're also capable of testing when you have a real HSM connected if you set up the right environment variable, which I've done with UBHSM. I have a physical one of those, and I've connected to Cloud HSM and run all our tests with those, and some manual testing as well. So,
is there any difference between the FIPS version of the HSM and this version?
That I wouldn't really know.
Well, there's the certification.
If you scroll down, they should say what they comply with. If you search for PCI, it's probably going to be in the list somewhere.
No PCI.
Or FIPS.
I know there's another one. Oh,
probably like a product page for it. Yeah, there you go.
Maybe it's just the encryption that it provides for FIPS.
Oh, yeah. So FIPS dictates what algorithms you can use, and they're not necessarily the most modern or the best algorithms, but that's probably like the non-FIPS version probably supports slightly more modern and better performing algorithms, but it is not FIPS certified. So if you need FIPS certification, use the other one.
Yeah.
And the other thing is like the FIPS certified version probably won't have any firmware updates for a while or ever, because every time you change anything for a thing that needs to be FIPS compliant, you have to go through the compliance process again from scratch, even if you change like a line of code. So vendors typically will not be very eager to make many changes after going through the initial thing. It's just really expensive to do.
Oh, okay. It says Yubico, if they make a change, they need to go through the whole like long month recertification process. Yeah.
Yeah, I don't know how long it takes, but probably months and a lot of money.
Mm-hmm.
So if you don't need FIPS compliance, if it's not imposed on you, probably using a non-FIPS version is better overall.
Yeah. And then AWS Cloud HSMs is the other option. So for the auth server and the CA in AWS, isn't it also stored in DynamoDB, or is it stored on the file system in a HA setup?
In HA, it would probably be Dynamo. So, I mean, with HSMs, all that we store in the backend is an ID of the key that we're using so that you can load it from the HSM.
So is there any other DynamoDB setup you need to perform for AWS? Or it just works out of the box?
No, so the way it works is that we put information about the CA into Dynamo with HSMs. So that's kind of the public key, the certificate, the type of the CA, all of the other like metadata. And then we put a reference to the key. So if you scroll up, there's somewhere backend schema section here. So if you scroll up a little higher,
I think it was down if you're looking for the
format of the
right
see this little format. So if you have a plain text private key, the private key field in the data that we store in Dynamo will have just that like PEM encoded key. But if you have a PKCS11 key, you'll have this little string that's in the middle, which kind of identifies enough of the key for us to load from the HSM the next time we start. So like when you're, first of all, the auth server puts its own host UID in, so it knows that this is, for its respective HSM and not some other auth server. And then it puts the key reference, which is, I think, what we put in the label or something, or like some attribute on the key in the HSM. So you can tell HSM, hey, give me the key with this label, with this UID.
Mm.
And then the actual private key is obviously stored in the HSM, which is a hardware device outside of Dynamo and unrelated to it.
All right, so this I think brings me to the end. I know we kind of like skipped over some of the backend storage. Is there anything of note you want to?
Like a lot of the backend changes were mostly about cleaning up the very outdated legacy way we were storing keys. So this is like what you're looking at is the old format. And it was kind of, okay, well, initially we had the SSH keys only. This is like the checking and signing keys. Then we kind of bolted on TLS and then JWT keys.
JWT, yeah.
And it's all kind of like a little wobbly. It's all very based on, it's like all of these lists of keys, and it's based on indexes. So the first item in the list is your active keys that you're signing with. And then the other ones are just trusted, but not used for signing. So it's kind of like, well, now if you have multiple keys that you're actively signing with, you can do the same approach because there's multiple of them, not just the first item in the list. So basically, all of this section of the doc was throwing out the old way, the old schema, and just creating a brand new one that works much better for the use case of having multiple active signing keys.
Yeah. And so I believe that this is now in 7.1. It's been merged. Am I right in saying that?
I think it's going to go to 7.2.
Okay. So pretty.
Yeah. As we were like ironing out all these CA rotation edge cases and stuff, didn't want to like delay the release, the 7.1, just to get this in.
Cool. Great. Well, I have learned more about HSMs than I ever knew was possible. Thanks for explaining it, Nick and Andrew. Is there any last closing thoughts on either this RFD or other ones that you're working on?
Not really.
All right.
Yeah, this is a good example of an RFD that gets updated during implementation because you figure out like different things, because it's a complex enough and novel enough area for us where we can't anticipate everything during the design phase until we try it.
Yeah, it seems like such a simple request, but I think this kind of shows the amount of detail, especially around, like rotation, that the complexity is like hidden until you start implementing and seeing how all these like different options and permutations that customers run Teleport in.
Mm-hmm.
Sure.
Cool. All right. Well, thanks, Andrew, Nick. Looking forward to doing this with another RFD soon.
All right. Thanks, Ben.
Thanks, Ben.